So basically we need to understand that overall concept of a solid principles, right? So solid principle is very much important when we are talking about object oriented programming. So you need to understand for the design patterns is one part, is apart from that you also need to have a good understanding of your basically for solid principles, right? So these five software development principles are guidelines to follow when building a software so that it is easy to scale and maintain. Correct? So there are many other articles you can find it out, but there is a basically what is the goal all about, right? So you will understand that what is the basically S stands for solid principles, right? Where a single responsibility. So a class should have always a single responsibility. Correct? So single responsibility means you cannot have in one class you can create a, let's say if you are developing a banking application, you can do everything into a one application one shot, right? So you can say I am responsible for doing all account related operations, I am responsible for doing customer related, I am responsible for doing everything. So all these things you should not do it. Okay, so basically what you need to do, you need to do basically have that single responsibility. That particular class should be able to perform only that particular task only. Okay, so if I am saying I am a chef, then you can see I am a gardener, I am a painter, I am a driver, I am responsible for basically in practical scenario for customer related operations, I am responsible for same class you are doing. So you, maybe some of the code I have seen into people have written that 10,000 line of code, everything you are putting into a same class, and it is very difficult to maintain, it is very difficult to add or any other new logic, very difficult to fix the bugs. So you always should have a single responsibility. Okay, so that you are not basically, when you have a single, there is a different type of cohesion, 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 different type of cohesion is there, right? So in that case you are not giving all other responsibility to that class. So that is, we will say, higher cohesive task, and for good design you should always, the cohesion should be very high. Okay, like this. So if you are writing everything into one class, you can divide it into four different class and you can give a single responsibility. So if the class has a many responsibility, it increases the possibility of bugs because of making changes. One of the responsibility could affect to all other without knowing it. So we should not do it. Goal. So the principal aim to separate behavior of the, when the bug arises as a result of your change, it won't affect to other unrelated behaviors. Another good design is basically open and close. So your particular design always should be open for extension and close for a modification. Correct? So it should not be required. If you will write this much lengthy code every time, if you are writing a particular structure classes, you have designed it, every time you need to go and change into a same code, into a same methods. In that case, it is there a higher chances of keep coming bugs, and maybe there is a chances you are manipulating a code which is basically very stable code. Okay, so let's say I can't cut, now I can paint. So the idea is basically when you are doing something, right? So basically you need to understand basically, so that when you are adding, let's say adding a new methods, if your class design should be like that, you can have, or maybe you can extend the class in some certain way or create a new classes, maybe you can add some much more methods in it, that is like that. But it should not be like that you are just adding a logic into same method, doing some much more if else conditions, all business logic you are putting into a same place, right? So changing the current behavior of a class will affect all the system using that class. Correct? So if you want a class to perform more functions, the ideal approach is to add the function that already exist, not change them. So don't change the existing behavior, you need to add some much more functions in that particular classes, like that. So the goal is this principal aim to extend the class behavior without changing the existing behavior, so that existing behavior will not be changed. Then you can have that there is a, you avoid causing a bugs whether the class is being used. correct. There is a basically then I is called as a Lisco substitution. If S is a subtype of a T, then object of a T in a program may be replaced with the object of a S without altering any of the desirable properties of the program. Means if class B is extents of a, so then object of a type of T in the program may be replaced the object of a S without alternating any desired properties. So you can just basically replace from the any subclass like that. So if I am saying
Can
I
you
have a
repeat this,
Sam,
Ashish? I'm not getting.
here we are saying if let's say class B extends A.
Okay.
So if let's say Eden is a child of a Sam, so basically here here is your coffee. So hey Sam, can you make a coffee? So basically what is happening here, at any point of time Eden can replace the object of this Sam.
Okay. The child object we can replace instead of parent.
Correct.
Okay.
If S is a subtype of a T, then object of a type T in a program may be replaced with the object of a type S without altering it. Correct? That is a like this. Correct? So if you will see, hey Sam, can you make me coffee? Here you will say, hey Eden, Sam is not here right now. Can you make the coffee for me? So basically you have replaced Sam from the Eden. Correct? Like that. So when a child class cannot perform the same action as its parent class, this can cause a bug. Right? So if you have a class that creates another class from it, it becomes the parent and the new class becomes a child. So when the child class cannot perform the same action as its parent class, then this can cause a bug. So the child class should be able to do everything the parent class can do it. This process called as an inheritance. Right. So the child class should be able to process the same as request as delivering the same result as the parent class. Right. So basically child can deliver as the same result as the parent can do. Right. So that is basically the goal is this principle aims to enforce the consistency so that the parent's class or its child class can be used in the same way without any errors. Now there is another question is for interface segregation. Very important point, very important concept. All just like your cohesion, you should also have that separate interfaces and for each and every particular task. So client should not force to depends on the matters they do not use it. Generally what is happening earlier before JDK 1.8, you need to implement all the interface methods, right? Otherwise else you can make the class as abstract, right? So you have to implement all the interface methods and you have to give some dummy you can say method implementation, otherwise you will see some compilation error. So you have to forcefully implement it. So rather than to doing this, you should make a separate interfaces so that you can put only those methods into an interface which is really required. Correct? So you can have a multiple interfaces and you can have a parent-child relationship also in the interfaces. And anyway, you can implement the multiple interfaces, a class, so you can make it as a multiple interfaces, right? So that interface segregation is very important point, right? You already know what is the pros and cons, so I don't want it to go into a. So that principle aim to splitting the set of action into a smaller set of actions so that the class execute only those set of actions if it is required. Now D is a dependency injection. High level modules should not depend on the low level modules. Both should depend on the abstractions. So abstraction should not depend on the details should depend on the abstraction. So dependency inversion we already know that, right? So we can also say that you don't need to call us, we will call you. That is also you can say that I cut the pizza with my pizza cutter arm. I cut the pizza with any tool given to me. So dependency inversion you already know, right? That's DI, dependency injection is also part of a dependency injection, right? High level modules class that execute any action with a tool. Low level modules are class they tool that is needed to execute the action. Okay. And any abstraction represents an interface that connect these two classes. Correct. And we can say details in how the tool works. So principle is saying the class should not be fused with the tools it uses to execute any action. So rather than it should be fused with the interface that will allow the tool to connect to a class. Okay, so we already know that. So you can say very simple language. It says that class and interface should not know how the tool works. However, the tool needs to meet the specification of the interface. If you wanted to perform, give some kind of implementations like that. Okay. So what is this? The principles aim to reduce the dependency of a high level class on the low level class by introducing an interface. So there should not be any more dependency on high level classes, basically from high level classes to low level classes if you are introducing any interface, right? So basically that abstraction, what can I say, should not depend on the details should depends on the abstraction. Okay, means what are the logic you are writing or things like that, right? Are you getting what I'm saying? So in that case, that abstraction at the interfaces points are should not be dependent on what are the tools or the action you are executing, right? So that action should be dependent on that what are the methods and things we are writing into an interface. Got it, guys?